I'm going to try to do a couple of examples here. Now this one is on page 438, and you might want to look at it while you're watching this video. I'm going to explain it as we go. So they have determined that 35% of all college freshmen live between 0 and 50 miles from campus. How they know that, I don't know, because normally you don't have that information. That's a parameter. We usually try to figure that stuff out, but we know that. Now, we take a sample of 1,500 college students. What is the probability that it's 35%? Now we're going to give ourselves a little wiggle room. So plus or minus 2 percentage points. So basically, our sample has to be between 33% and 37% of those kids are between 0 and 50 miles from campus. Okay, let's work with that. Now, first of all, we have to do a couple of things. The first thing is we got to figure out, is our sample 10% or less than the entire population? So we think about that 1,500, so that would be 10 times 1,500, which means are there at least 15,000 college students? Now that's not just for one campus, that's in general is what we're talking about. All college students, of course. There's way more than that. We talked about that during class. Also, we have to say, can we assume normality? Now the way that we can do that is, and we did this before Christmas break, we take our percentage and we say, so to assume normality, we have to say, okay, here is our, where is it? Right here. We say the number in our sample times the percentage. Is that bigger than 10? Yes, it's way bigger than 10. Well, what about the number in our sample times 1 minus the percentage? 35, 65, they equal 1. Okay, that's also bigger than 10. So we can assume normality from that. Now over here, we're going to say that if we took all the possible samples we could possibly arrange for college students as far as like how far they are from home, and we took the average of all these probabilities, these samples, we took a ton of samples, every possible one. If we average them, we would get 0.35. Now that's called an unbiased estimator, which is kind of complicated to think about, but it's this. The average of every single sample and the proportion of every single sample we could take. If we take the average of that, it's equal to 0.35, which is what we thought it is, or actually they told us the parameter is. The parameter is equal to the sampling distribution, unbiased estimator. Got to remember that. Okay, let's move on from there. So once we have established the 10% rule and the fact that we can assume normality from all that 10% stuff, and it's an unbiased estimator, now this stuff is just as a reminder, remember this, so this is our standard deviation, 0.35 times 0.65 divided by how many in your sample, take the square root, here's our standard deviation. So we can do the z-score. Remember that? Okay, here we go. Z-score, so from the high and from the low. So we're going to say the part that we're interested in minus 0.35, which is what our population is, divided by the standard deviation. And then, of course, we take the other z-score and we take 0.37 minus 0.35 and divide it by standard deviation, and we get these two numbers, which is negative 1.63 and positive 1.63. What does that mean? Oh, that normal curve. So we are 1.63 standard deviations away from the middle, and how much area is that? So let me put another slide up here and take a look at what that looks like. So let's remember a couple of things. Here's one graph. Oops. The average of all those percentages from all those samples we could possibly take was 0.35. And we want to know this area between 0.33 and 0.37. This area in here. Now using the z-scores tells us that we're at 0, and how many standard deviations are we? We are at negative 1.63 and positive 1.63. Basically the same graph, but this is normalizing it. That's why we do that z-score thing. So how much area is between there? Well, let's find out. Oops, I forgot to put a negative right there, so I fixed that. Let's go to the next slide. So I go into the calculator and use second vars, and I'm going to go into normal CDF, and my lower is negative 1,000 and my upper is 1.63, and that area, all of this stuff all the way down, is going to be 0.9484. So that's that area under the curve. Whoa, slow down there, guy. Right there. Now, so I'm going to do the same exact thing. I'm going to go into second vars and normal CDF, and now my lower is going to be negative 1,000 way down here, and my upper is going to be negative 1.63. How much area is right there? And it turns out that it is 0.0516. 0.0516. So what we do is we subtract these because we want to get rid of the overlap right here. So if we take this part away, we end up with just the part that's between those two boundaries, and it turns out to be 0.8968. 0.8968. So, what do we conclude based on this situation? If we took a sample of 1,500 college students, we would have close to a 90% chance that the percentage would be between 33% and 37%. Ta-da! Well, boy, that's a lot of stuff. But hopefully some of the stuff you remember from last semester, we're just piling it all together and we're putting into it into a different context. Okay, now I think I'm going to stop the video here, and I'm just going to make another video for our next example so these videos don't get too long. Okay.